So let's get started. First, I want to thank the sponsors that put on this awesome conference. So without them, we wouldn't have this conference. So that's pretty cool. So a round of applause for the sponsors. Yeah. To introduce myself to you, my name's Blythe. I've worked in software for about 15 years. I've contributed code to a number of open source projects, including Chef and a lot of Chef cookbooks, like Hubot plugins, and a bunch of other projects. I've had the title of software engineer in the past, where I'd write code all day. Then I had the title of software architect, where I'd write code when I wasn't in meetings most of the time, or drawing boxes and arrows on the walls and stuff. And currently, I'm an automation and system engineer. But most importantly, I'm a level 25 Pokemon trainer. And I've also organized the DevOps KC meetup for the last 4 years. And we're organizing our second DevOps days in Kansas City. So I made the drive across state last night to be here with all of you. And we'd love it if you guys here in St. Louis submitted proposals or drove over in September to attend DevOps Days Kansas City. We're in the Uptown Theater, which is pretty cool. So I've attempted to create an experience where if you'd like to follow along with the slides or recreate anything that I'm going to show you today, you can do that. I tweeted out this link just a bit ago, and my Twitter handle should be in the bottom right corner of all the pages. So personally, when I leave a conference, I always leave with this thought of I should spend time doing that awesome thing that person showed me how to do, but then there's never time. And plus there's a bunch of setup time to even get to where they're going. So I'm trying to take this from the ground up here, and all the stuff I have in my slides you should be able to copy and paste directly out of. I haven't actually tested the PowerPoint, but I know with Keynote it's all copy pastable. So today I'm going to show you how to actually do a couple things with my two of my favorite tools. One of them is Test Kitchen, the other one's Inspec. Test Kitchen was reimagined in 2013 by Fletcher Nickel, who now works at Chef. And I'm going to do live demos because, hey, it's going to be entertaining for you if I fail. So that'll be fun. So we need to start with what Test Kitchen is. Put really simply, it's a harness that allows you to create machines quickly. And then test that configuration that you have, and then just throw the machine away. And by quickly, I'm talking about several minutes to less than a minute. So let me repeat that. So the software we're going to look at today allows you to create an entire machine with your full stack on it in a couple minutes, as opposed to the alternative. So let me put that into perspective compared to where I was at as a developer a few years ago. If I was looking to acquire a VM in 2013, which is the year I started using Test Kitchen, in an enterprise environment, I was looking at roughly 3 months wait. We did have a self-serve on-prem VMware cloud, however it was brittle, and changes to images weren't really allowed. You could log an issue, but it wasn't going to get prioritized, so the machine was pretty much like the vanilla machine that they had given you. So we used Chef, but it was for these long-running virtual machines that would live for multiple years on end. And they were initially configured by hand before they were even given to us, so that part wasn't automated. And the machine that you received today wasn't going to be the same machine as what you got for 3 months ago. So as you're going to see, Test Kitchen is quite versatile. There's drivers for all types of machines and containers, from Vagrant to Docker, and all of your favorite cloud providers, from Azure to AWS and Google Platform. There's even one for Terraform that I'll go into a little bit. And there's provisioners for all your favorite configuration management tools. So Chef and Puppet, Salt, and Ansible. And it's going to work with Windows or common Linux distributions. And it's going to allow you to test those resultant machines in either Inspec or ServerSpec or Pester for PowerShell, Bats, and a bunch of other testings. The easiest way to get Test Kitchen is to install Chef DK. That's even if you don't use Chef, because this package is going to lay down an embedded Ruby, and it's going to install the Test Kitchen gems and all the things you need to use on that embedded Ruby, so you don't have to mess with installing Ruby. If you're on a Mac, then I highly recommend you use Homebrew to install and upgrade the tools that you need. Since these are applications, you'll use the Cask type of install. And I found that these casks are really well maintained, and I haven't ran into very many issues. We'll go over VirtualBox and Vagrant in a second, but those will be integral to this. If you're on Windows, I would also recommend using a package manager to give you these command line installs and upgrade processes that's common in Linux distributions. Chocolatey is an awesome tool for this. It's maintained by Rob Reynolds from Puppet, and it has a solid package management for all of these tools. So once you have those installed, I'm going to start with Vagrant because it's the simplest. So with Vagrant, we're going to be spinning up an Oracle VirtualBox with many different OSs. I'm going to start with Windows since it takes the longest to spin up, and I already have one running, because you don't want me to just fill time for 10 minutes while it's up and while we get it up and running. So here we have the kitchen.yaml. Can you guys read this? The red's a little hard. Oh, I thought the lighting would be different in here. I'm sorry about that. This is a basic YAML file. If you're familiar with these, it's way better than JSON if you're a human. It has some limitations if you're a computer compared to JSON. But basically, this is how we're going to define all of our kitchen files. This one's for Windows. And the specific thing here, the red's a little bit hard to read, is that I'm setting up a private network on my machine with an IP address. And then the platform I'm using is a Windows box from Matt Rock. And the transport is WinRM, and my privileges are elevated. So now I'm going to switch over to this .kitchen file, which will take me a little bit so that you can see what I can see. And we're going to go with this. So first thing I'm going to do is I'm going to actually export and make sure that I'm using the Windows kitchen.yaml file. This is an environment variable. It tells Test Kitchen what to run. And then I'm going to make sure that that actually is set. And it's going to tell me that I'm using Matt Rock's Windows box. In Vagrant, it's going to provision with Chef 0, and it's WinRM transport. So I've got my Windows box, and I'm going to converge it. So what it's doing here is it's already detected that Chef is installed. It's transferring the cookbooks to the machine, and it's going to run Chef. Since I've already run everything, it should be idempotent, and it runs in 27 seconds, which is pretty cool. So now I have a Windows machine running on my Mac here that has IIS up and running. So that's kind of cool, right? But here's the cool part, is that I can actually log into this machine. And I'm going to not actually select a folder here. I'm just going to, because I don't need to present any storage for this simple example. I'm going to continue through the local networking and then log on. And there we have it. So on my Mac, I have a Windows machine up and running in running about 3 commands in less than a minute. Yes. Yes. And if you have lots of them running, we'll use a lot. So I'm going to log out of this machine. But yes, it's using all the resources on the host machine where the virtual machine is running. So this is very similar to like when you run VMware on a host, but instead of the host being like a Blythe server in some data center somewhere, the host is your actual laptop. Okay, so I'm going to switch back over to in my presentation. Okay. So where do you get these Windows images? Windows has licensing where you can use these images for 90 days. The easiest place to get them is directly from Microsoft. They have developer images that you can, they have like a variety of operating systems and browsers installed, because a lot of people set up like a whole matrix of tests to make sure that their web page is going to work on different browsers, on different operating systems. I personally use the ones from Matt Rock. He now works at Chef, and he's a really smart Windows dude. And he's created all kinds of really good resources around this space, not just these Windows images. If you want to create your own, you can go to Joe Fitzpatrick's, or I knew I was going to do that, Joe Fitzgerald's Packer templates, and then you can download those Packer templates and you can create Windows machines fairly quickly. By fairly quickly, usually we have people kick it off at night when they leave, and then it'll be ready by the morning. Because it does take about 4 hours to create those Windows machines, and they end up being about 8 gigs. I was taking a networking class at my local community college, and some of the resources were only available on Windows, and I wanted to use my Mac, so this was actually what I ended up using for that. So I did cheat a little bit. This did take about 30 seconds to run in here, but beforehand it took around 10 minutes to get that Windows machine up and running. We already did this where we logged on to the machine, and we saw that the web page was up and running. So now let's take a look at some Ubuntu and Red Hat distributions. I believe that this is the file that you get if you just scaffold a new cookbook from Chef. The driver is Vagrant. The provisioner is Chef 0, which is pretty much Chef Solo, which just means it's an in-memory Chef that doesn't connect back to a Chef server. So it's all contained inside of this VM. The verifier is going to be Inspec, which we're going to go into in depth later. And then I'm going to actually create 2 machines, an Ubuntu machine and a CentOS machine, and then I'm going to run a very simple script, Chef script. So let me swap back over mirror displays and clear this off. Let me destroy that other box because I no longer need it. And as pointed out, that's going to take up resources on my machine. Then I'm going to switch over my environment variable to point to the kitchen.yaml that I want. I'm going to list out so that we can see we're going to create both an Ubuntu box and a CentOS box. And then I'm going to converge. And this is going to take a couple minutes to run, so we'll pop back over the presentation. But first, I'm going to grab my notes. So the first time you run Kitchen Converge, what's going to happen is it's actually going to pull down these images from the internet. Or wherever you've defined those images to be. So you create these VirtualBox things. I already have them on my local machine, so it's going to be quite a bit quicker. This full run should take a couple minutes. The Linux distributions are around 1 gigabyte in size. The Windows ones are sometimes as much as 8 gigabytes in size, so it's going to take a while. Personally, I have Google Fiber in Kansas City. So I've got gigabit internet, so like a lot of times I don't even think about that. So I had to think forward to here where I'm only getting about 20 down. So here you see VirtualBox. If you've ever seen VirtualBox, like you can, you're familiar with this. It's going to create these 2 machines. One's Ubuntu and one is CentOS. And when I started using Vagrant many years ago, I loved it because it made VirtualBox something that I could more easily interact with. At that time, I didn't know like all the settings and stuff. Like I said, I was logging issues and people were just giving me machines, and I couldn't change anything unless I went on and typey or ran a chef cookbook. So Test Kitchen has made this even simpler for me. Test Kitchen kind of builds on top of Vagrant. And over time, because of Test Kitchen and Vagrant, I've learned what a bunch of these settings are, and it's actually made it a lot easier on me. It's actually a little bit different than that. Like, so instead of you creating a server in some shared space where someone else can see it, you're just creating it in the context of wherever you're at, doing something like converging. Now, converging kind of comes, the word, do you guys know what converge means? So I see some people say, what's that? Putting things together. It comes from, prior to Chef and Puppet, there was CF Engine, which was created by Mark Burgess. And he had this theory of convergence, where you define the end state of what you want, and everything converges on that. He's got a really great paper where he talks about this is how GPS systems work, is that you work from the destination back to where you're actually starting from. A lot of times as humans, we always forward think. Like, I'm right here, and I need to get to this destination. Like, the theory of convergence is the end state is your app is up and running on the machine, and where everything's going to converge towards that. So sometimes you'll have chef cookbooks that don't run successfully on the first try, then you run them the second try, third try or whatever, and you're trying to get to that actual state. These are bad cookbooks, but the idea is right, that you converge to that. So the repeatability, I think, that you're looking for, it's not like you give over a machine to someone and it's in some running state. You give them the file, that kitchen file, and then they run it on their machine, and it does the exact same thing on their machine that was done on your machine, which in the past took so long. Now that's quick enough, like, we're talking of several minutes, and they can just repeat what you did. What's that? You could potentially, we'll get to that when we do our CI/CD stuff. The GUI is in VirtualBox, but everything else is command line. And I'll show you why that's important when we get to... you can do settings. Let's see. You can do settings in here in this YAML file that manage if you need more memory or if you need more drive space and stuff. Great question. The GUI is in VirtualBox, so you could, when you create them in the Packer templates, you could also do that. Let's go back and check in on this. Okay, so it did run, so I'll show you that. So it finished converging. Here you can see the output, which is quite a bit of the CentOS run, and if I scroll tons, don't look at the screen, man, that's weird. Let me grab this. You can see the output of the Ubuntu run. So what we want to do with this machine is let's list out what's there on that these two machines. We've got the Ubuntu one and the CentOS one. I'm going to log on to the Ubuntu one, and it ran a very simple chef cookbook that does a one-page HTML file that says hello Kansas City, because that's where I came from. We're going to go into the code now and change that to St. Louis. Is that all right? Or should I do St. Charles? Does it matter? Well, let's go with St. Louis. So I'm going to exit out of this machine because right now I'm inside the virtual machine. And then I'm going to run a converge, and then I'm going to take a question.
So this like directly just run this thing for servers, right? So how much processing power does a computer need to run the virtual server?
What's that now?
So you're hosting the virtual server on your desktop or whatever. How much processing power do you actually do that? How much you want?
We actually had problems at my previous gig where this was a little bit too much for some of the weaker machines. I'm running a fairly nice Mac here where I've got 16 gigs of memory. And when I get like 2 or 3 or maybe sometimes as many as 6 machines running, I'll exhaust quite a bit of that. As far as the CPU, let me see if I can find these. When it's idle, it's not using most of the stuff. But again, this is we're just spinning stuff up, testing it, and throwing it away. So this is not for long-running machines at all. So I switched that over to, say, St. Louis. And now I've got my web page up and running. Let's see here. Let me go.
Aaron, if you're doing a Windows machine, would you use this in conjunction with PowerShell to get through the initial configuration, or do you do it all in Kitchen? If you wanted to set a particular set of environment variables and things like that.
So if I was using a Windows machine, I would probably start in PowerShell and I would run the kitchen commands to run all this stuff. Chef has really good integration with PowerShell, so it stands to reason that it should work pretty good. So the thing that I changed here was that I actually created a private network, and you guys can't read this because of the red, but it's just running on 192.168.34.34, and that's the web page that I went to. So like a lot of those settings that you can do in VirtualBox or in Vagrant, you can just put right here in your kitchen file, and then you can do local networking, which has helped us out quite a bit because a lot of times what we want to test is the interaction between 2 machines as opposed to just the configuration of a single machine. So I converged that, we opened it up, and I changed it from Hello Kansas City to Hello St. Louis. I'm going to run back and destroy that real quick because I don't need it any longer. I'm not going to mess with showing you the destroy because we've already seen one of those. So we can get back to this. And this one's my favorite, which switches over from Vagrant into using Docker until I actually run into issues. Or do we call this Moby now? Does anybody understand the change that happened recently? I'm still trying to figure it out. The Docker project, I believe, is now called Moby for the open source stuff, and the open source stuff is the stuff that I use. And okay, but what I'm about to do isn't the standard way to use Docker. We're actually going to use Docker as a mini VM instead of Docker's original intention, which is as a container. And then we're going to run Chef inside of that. So the reason we're going to do this is that Brigade Engineering made a fairly strong case for using Docker in this way in March 2015, about a couple years ago, when they showed that they could get their matrix of tests where they took their architecture, ran it, a whole bunch of tests, they spun up a bunch of machines, and then brought them back down after they had run their tests. It took 2 hours, they brought it down to a half an hour. So I guess if this is the wrong way to use Docker, I don't want to be right. Because like when I'm developing code, I'm attaching a debugger, right? I'm using Visual Studio or whatever IDE that I'm doing. And I know that this isn't exactly like production, but I do things to make things faster. Like inside of Visual Studio, a lot of times I'll use the flag to not recompile the entire project, but only recompile the part that I've changed. So we take our kitchen.yaml file that we've been using. We now change the driver to Docker. We're going to forward port 80. And then we're going to set use sudo to false. The reason we're going to set use sudo to false is simply because it works. Again, we're kind of hacking things here. So when I switch over this, I'm going to go ahead and clear so we get up to the top. List out, and so I kind of glazed over this, but I'm using the Chef installed kitchen, so I'm using Chef to exec this to execute this command so that it runs on that particular Ruby because I have quite a few other Rubies installed. And then I'm going to run kitchen converge. If this works, we'll see how fast it is. So first thing it did was it brought up the Docker image, which I already had installed. Yesterday when I did this, they had created a new Ubuntu machine. So this did actually take a full 2 minutes or whatever. The part that may take a while is this is going out to the internet installing Chef. That actually was fairly fast. Now it's unpacking Chef and getting it running on the machine. Should be transferring over the Chef cookbook, and now it's running the Chef cookbook. And as opposed to the 2 minutes that this was taking before, this is actually from scratch. It's pulling up the Docker image, running all my configuration, and we should have the full application running in about 30 seconds. Watch it take.
Some of the gotchas in the configuration settings that we're showing.
What's that?
Any particular gotchas in the configuration settings that are worth showing how it's spinning up? Things that you've learned through experience that, as far as settings that to use or not use.
Well, let me see. That's a great question. The kitchen.docker that I have checked in, I have a few things commented out. Let me command plus that a little bit. If you're familiar with Docker, to get this running in Jenkins, I don't know if you've ever heard of Docker in Docker. It was created, and then the person who created it said, this is a terrible idea, don't do this. This is only for testing so that I can create better Docker for you. And then there's a Docker outside of Docker, which we refer to as Dood, D-O-O-D, where you actually mount the sock or the socket port here. And to get this to run in Jenkins, where I had all of the workers as Docker, and then actually doing Docker outside of that, I used Dood. And the way you do that is actually to mount the Docker socket here. So, don't know if this is going out to the internet to install this. So of course it's going to make a liar of me. The Docker's not being as fast as I expected. Given that I have a lot of slides and we got started kind of late, I'm going to start burning through some slides, and then hopefully we'll have time to discuss things at the end. Let me switch back to... So when this runs and we come back to it, what we're going to see is that actually just we can use our Docker commands, like docker ps-a, and we can see that we have one running. So that's all well and good, running local machines. And I think you guys were kind of asking about this. VirtualBox and Docker and stuff, that's great for development. This is like running something in an IDE where you hit play and it runs or whatever. But when we take this to the cloud, whether it's Azure or AWS, what will happen from the initial thing where you're actually running your machines more like code locally is you're going to get rid of a bunch of configuration problems because you're going to figure out the configuration problems earlier. You're going to move that left in your development cycle. So then you're going to be left with the problems of, I'm using VirtualBox and Docker and this is nothing like production, right? So there's an actual driver where you can do this on Azure or EC2. I'm more versed in AWS or EC2. So to get this set up, I set these environment variables, which are my secrets, that shows that it's my account that I'm connecting to, and which security groups I want to use and stuff. And then I take that kitchen YAML file that we've been modifying repeatedly now, and I actually take, in the red here where you can't see, it's actually environment. So it's reading those environment variables into here. And then the transport is my SSH key, which I have, which connects me into AWS. And then I'm actually using a specific AMI. So then I'm actually testing on the same type of machine that we are running all of our applications on in the cloud. So if you don't have this kitchen EC2 plugin installed, you have to install it. Given the Wi-Fi here, I'm not actually going to show you this. It works the exact same. We export the kitchen.yaml file that we want, and then we run converge, and then it runs in a machine out there in the cloud. So we haven't known each other for very long. In the short time that we have, I've created and destroyed many machines and containers. But I want to tell you the story about this place that I worked. There were machines that had been around for a decade. They were named after the Rat Pack. You know, Sammy, Frank, Dean, the whole crew. They were built by hand by many different engineers over the course of many years. And over time, you develop this relationship with Frank, right? He's got a personality. You have these good times, you have these bad times, maybe sometimes you share some whiskey. In a situation like this, no one wants to be the one that kills Frank, right? Everyone's afraid of being accidentally the one that kills Frank, and no one wants to be the one that gets rid of the server named Frank. So you have this relationship. So I want to suggest something different, a different type of relationship with your servers, which I kind of refer to as like Gangnam style, right? You have your server, your VM or whatever, you create it, and then you blow it up and you walk away. So for the Kitchen EC2 one, if I had faster internet, we would log on to that, and we would see that we can get right on and then we can destroy it. So maybe Chef's not your thing. There's many different plugins to use here. You can use one for Puppet, Ansible, or Salt. The configurations for those are as such. They're a little bit more involved. Remember the provisioner for Chef, we just said Chef Solo. Here you have to actually put out a few more things. The Salt provisioner could probably use a lot more work if you're into contributing for something like that. But the Kitchen and Ansible ones are fairly active in the community, and they're getting updates regularly. So spinning up a single machine is great, but what if you could spin up your entire infrastructure this way? Meaning that like your security groups and all the stuff you do in Azure or AWS, that would be super awesome. So there's this active project that I've been watching from New Context that allows you to bring up a Terraform stack in the context of Test Kitchen. It's been maintained by Aaron Lane, and there's a great talk from DevOps Days Chicago by Nell Shamrell Harrington that explains how she refactored her infrastructure using this. There's also Kitchen CloudFormation if you use AWS. This also comes from Neil Turner, who did the Puppet and Ansible plugins. This one's not as popular because JSON's really hard for humans. Recently, CloudFormation has moved to actually being YAML also, but this one hasn't been getting as much love recently. So we've used Test Kitchen. We've got machines. We're spinning them up real quickly. Now we want to test them. The way that I test them is Inspec. Inspec provides us that behavior-driven development for our machines and infrastructure. So if you have used RSpec or Cucumber, JBehave, EasyB, or other behavior-driven development frameworks, you know what I mean. And if you don't know what I mean, that's cool. We're going to go over it. So resources are the key to this. They're fairly comprehensive as far as the things you would regularly do to a machine. So I'm going to go back to our kitchen.docker. And instead of converge, where I just get the machine to the end state that I want, I'm going to run kitchen verify. If the machine hadn't been converged yet, this would converge it, and now it's going to run all of the tests. As you can see, I had 21 tests that were successful and one that was a failure. The one that was a failure was because I had a very pedantic test in there that said it has to say Kansas City, and now it says St. Louis. But all these other things that I've checked all passed. So if you've ever taken a class on Chef or Puppet, maybe you've heard of the Trinity of configuration management. You install a package, you manage the service that's running, and then you manage the configuration files that make that service your thing for your business. Notice that I don't say Holy Trinity, I say Trinity, because Trinity is freaking awesome. I could watch that like all day. Here's me doing the whole Matrix thing at a different conference where Google was there and had these awesome cameras set up. So I love RSpec because of how readable it is in general. With Inspec, we now have resources to make this a lot easier. So instead of writing like some type of PowerShell or like Bash scripting, you can simply say, let's describe the package of Apache 2. It should be installed. And that's the test. So that's going to run on all the different places that you can actually converge code. Describe the command Apache 2-v. Its exit status should equal 0. That's a little bit more technical, but that just means that it should succeed, right? And its standard out should match Apache server version of 2.4. So that's our install package. That's our first in their trinity. The next is a service. I can describe the service of Apache 2. It should be installed, and it should be running. This is one of the tests that I had that passed earlier. And then configuration files. Some of your configuration files resources in Inspec are very specific. So the Apache config, if you're familiar, has things like listen. So I'm just saying its listen should equal 80. So it should be available on port 80, which is why I was able to bring that up in the browser so easily. And its allow override should contain none, just because I tested what the default was in there. What I do more often is actually describe a specific file. So I took that, that one page that we kept on bringing up that says hello St. Louis now. I said the file should exist. It should be a file, and it should be owned by root, and its contents should match Kansas City. So even if you're not the most technical person on your team, you can read these tests, and you can also read the output. So sometimes your tests are going to be slightly different from one OS to the next. Inspec has you covered there. You simply say, if the operating system family is Debian, then let's do it this way. So if you're familiar with the Apache web server, you know that the installation package and the service that runs on Debian or Ubuntu is Apache 2, and for whatever reason, Red Hat has decided that's going to be HTTPD. I don't know who decided first, but for whatever reason, they've never converged those to be the same thing. One note I will say, if you're familiar with betterspecs.org, and this kind of is a way to write better specification tests for behavior-driven development, they say that you should use the exist now instead of the should, right? But Chef did a survey, and they said most of their users were still using should. And the reason that they stuck with should is the blocking that comes from the output of the test. So now I can see, this is beautiful to me to be able to read. I can see that this particular file, Apache 2, should exist. It should be a directory, and it should be owned by root. So again, if you're not the most technical person, you could be the one triaging that there's a problem in your CI/CD pipeline, and you can be like, oh, this file's messed up. I know that that's this particular engineer, so I can go to them. Whether or not you've checked out DevSec.io, I highly recommend checking this out. It was created by a company that was originally called VolcanoSec by Dominic Richter and Christoph Hartmann in Germany. It was recently bought by Chef and integrated into their Chef compliance. But there's a lot to dig into on their open source side. So Supermarket is where you go to find community cookbooks for Chef, but there's also a tools and plugins page where down at the bottom they have compliance profiles. And there's compliance profiles from this open source consortium of DevSec where they have basically the CIS profiles. You can pull this into our kitchen.yaml directly from Supermarket, or you can put it on a network drive, or you can check it into GitHub, or you can put it on a URL somewhere, and then you can run kitchen verify on that. So I did this on a Docker image using basically the Linux baseline that tells you what you should have for security for a base Linux machine. And I just ran it on Docker, and I got 24 successful and 26 failures. But these tests are super awesome because the Docker image, this just doesn't match up right because a Linux box and a Docker image are different. But you can see that I ran this. I'm not sure if I have the time that this took. I was blown away that this runs in about 10 seconds. All these different tests. So the great part about DevSec.io is there's a corresponding Chef cookbook, Puppet module, and Ansible role for all of the tests that they have for these baselines. So if you're not in compliance, you can just pull those cookbooks or roles on, and then you can get into what they consider to be compliance. So maybe you don't agree with that. That's great. You can fork those configuration management tools and change it to what you want. However, those actually, their compliance profiles come from the rules at the Center for Internet Security. So you're starting with a baseline of saying your machine is already up to a certain standard. So if you have any type of regulations or whatever that you have to show compliance, this is an awesome way to do it. For those of you that are like, well, I'm DevOps enlightened, I no longer use VMs, I only use Docker, I don't run configuration management inside of my Docker container, I use Packer for configuration management to build my Docker container, that's super cool because you're also covered. You can use a provisioner of shell instead of the configuration management tools I was talking about earlier, and then you can say which Docker image, so the Docker image that you're creating for your company, and then you can actually run, I ran the Linux baseline before, you can run the Docker benchmark against that to make sure that your Docker container that you're creating as your company is actually compliant. This is super cutting edge because it only came out last week, the ability to do this. So you would have to hack this in at this current time until the next version of Chef DK comes out. I'm going fast because I'm supposed to be done in about a minute. So, can you do this in continuous integration? Absolutely. You can do this in continuous integration. The tests or the project I've been showing you is actually running in Travis.ci. The way I did this was I used Kitchen Dockin, which is a little bit different than Docker. It's created by Sean O'Mara at Chef. And if you go to the link that I tweeted out and just go on the README and click on this build passing, you'll see the output of this running in Travis. I've actually got similar things running in both Vagrant and Docker on Jenkins. So in conclusion, I went kind of fast there at the end. I hope you see the benefit of this test harness and this line of thinking. Testing this way has saved me a ton of time and made our infrastructure way better because we don't have the problems later on. We see the problems much earlier in development time. So if you try any of these things out on that link that I posted on GitHub and it doesn't work, use the Issues tab and let me know. This page is kind of a credits page of all the awesome stuff that I showed and the people that created it. Open source is awesome because of people like this that create things and put it out there for others to use. One person I didn't mention was Mitchell Hashimoto, who created Vagrant and kind of started this whole thing off. And he's also created Packer and Terraform, which I mentioned, and a host of other tools from HashiCorp. So I think that's time. We'll probably have to let the next speaker in. But if you guys have questions, come and see me or whatever. And it was awesome to hang out with you guys for the last hour.